Okay, verify. So remember that when you verify, you're trying to make one side look like the other, and usually you start on the more complicated side, which probably means the left. What might I do to simplify on the left? What do you notice about it? It's got secant squared twice, doesn't it? There's a secant squared as a common factor. So what are you going to do with it? Factor it out, right? Take the secant squared outside of parentheses. What's left from the first term? Tan squared, right? What's left from the second term if I factor out secant squared? Plus 1, right? Now, what substitution could I make with it? What's that? Right, you go to these identities and you notice, well, 1 plus tan squared, that's secant squared. So replace it with secant squared. Right here, right? That's the same thing as secant squared. So write it as secant squared x, and now this becomes secant squared x. Now remember, when we write this 2 in between the secant or the trig function and the x, it's just like saying secant of x squared. Right? So now we're multiplying secant squared x times secant squared x. How many secant x's? We got 4, right? So that's secant to the 4th, which is that. So whenever you see common factor, that's generally a good way to go. Remember, there's more than one right way to do all of these things. The verifying identities, it doesn't have just one way to get there. I mean, in the end, it does have to make the left look like the right in some way. But there's more than one way to get there.